Hello and welcome to the session on Docker Essentials. My name is Prasanjit and I'll take you through various aspects of Docker containers and the essential command line tools which we use to manipulate Docker instances, run them, create images, and deploy some real world applications using Docker. So, the agenda will be what is Docker, understanding that, what exactly it is. We know it is a software, but how does it help us? What are the applications, use cases? So we'll learn that. Then we'll learn why we use that. What was the other alternative of Docker? Why it wasn't good enough, and why Docker has replaced the alternative. So we'll understand why Docker has come into being, and then we'll see some statistics, like is it worthwhile to spend time learning about Docker. So some statistics about the market and what people are doing will help us. Why I'm saying this: for example, you go on, I ask you to learn a programming language. If you go and learn COBOL or Fortran, any older language, will that help you? Because it would not, right? Because no one in the industry, not many of them are using these are languages for mainframe computers. So now if someone asks you to learn a computer language, mostly they would recommend you to learn Python or Node.js, JavaScript, and all this stuff. So what does that mean? We only learn about relevant technologies so that we can apply solutions to whatever currently is in demand. So now most of the companies are moving towards Docker. So once we know what and why Docker is being used, we'll also see the statistics, like how many companies are using, what are the benefits they're getting, and so on. So that will give us an idea how much time to spend on this course, and why we should learn Docker. Once we understand that, then we will today's will be more hands-on, because it is a software which you have to use to understand. You cannot just go on hearing lectures or reading notes. We already have notes there. I'll share the link with you. But today we'll install Docker and see what it does and how it works. And then I'll be again coming back and forth to this slide and explain you some concepts on Docker and various commands. How is the entire life cycle of Docker working? And then in the end, we will discuss about container orchestrators. We'll not cover in depth into this because these are advanced DevOps topics. But until reaching about learning orchestrators, we'll get a fair bit of idea of what is going on and what we are going to do. And finally, we'll try to do these three hands-on. It will take time, but it will be good to be able to complete this by the end of this session. So there we will try to create and deploy some containers using Docker. We will try to build a Docker image and then deploy it. You might have remembered in the previous session, we had a static website for our demo when we were doing the Git and GitHub. We had some code which we created and put on a repo. So we will use the same code to deploy it. So we'll see how it looks like when the code is deployed. So later on, when we automate the process, that will help us to build a good automated CI/CD pipeline. So we will do the deployment today manually on Docker using the same code that we had in the previous session on our repository. So we'll see how that code looks like when it is deployed on a server or a Docker container in this case. So these are the things we'll be doing today. So let's begin what Docker is. So before telling you this, just imagine you have come across virtual machines, right? When we have a virtual machine, how does that help us? Because we have been using virtual boxes every now and then. So here we have a virtual machine inside it, and there is an operating system running inside the virtual machine, Ubuntu 64-bit. But the base system here is Mac OS in this case. Similarly, you have tried this on Windows also, so you know better. Like when a Windows system is there, already it is operating system, and over it you have a virtual machine, and inside it you have a Linux system running. So you have a operating system inside a operating system. So you can run 2 or 3 or 4. If you have a lot of memory and CPU, you can run 5, 6, 7, 8, and so on. So you can have multiple virtual machines inside the one operating system. So you can have multiple operating systems inside one operating system. So here you are creating a nested system of operating systems. So what does that mean? So a virtual machine is allowing us to isolate various softwares or operating systems into multiple different entities. Like for example, we have a Mac. On it, we have different isolated systems. Like what we do in Jenkins, this guy base image doesn't know. If we add some new server and do something on that, this Jenkins would not be affected. If I delete this base image, Jenkins would not be affected. So how does this concept help us? This helps us by isolating our uh, operating systems. So it isolates the environment. For example, now I will create a new server and put a dev environment in it, and I will create another, put a prod environment. So if I create different environments in different VMs, then they would remain isolated. So this is one important concept that will help us in future when we do the environments and deployments. So the concept is virtual machines can help you isolate environments because they are independent of each other. Each one has a different IP. Each one is behaving like a full-fledged uh, operating system, because actually we are installing an operating system inside a virtualization framework. So this is the concept about VMs. So why I'm talking about VMs? Because these VMs have certain disadvantages. We talked about the advantages. It allows isolation and all, but it has a disadvantage. These are, I mean, resource heavy. Why? Because they are running the operating system on them and also running the applications inside it. So if I am running Jenkins on Ubuntu, that means I have Mac OS, on it I have Ubuntu, on it I have Jenkins. So you have 3 layers. So it becomes slow. It takes more memory and so on. So if you have 5, 6 virtual machines, it will slow down because the operating system running on it is accountable for certain resources that is being consumed. So this is a disadvantage. I have discussed more about this here on the tutorial. Let's keep this one open as well. So when you go through the notes later on, you will understand. So first we are discussing this part, like what is a virtual machine. These are definitions. You can go through them in your time. So this is the definition, like what a virtual machine does. It separates the environment, isolates it. Every virtual machine runs on a software called hypervisor and all that. Hypervisor means this virtual box is the hypervisor here. So if you are using VMware, that is another software, that's the hypervisor. So virtual machines allow you to run a nested operating system, like you're running operating system inside another operating system, and within that you can run your applications isolatedly. So these are the advantages, but there are some problems with the virtual machines. What are the problems? This one I already told you, they're bulky in size, running multiple leads to unstable performance. Remember last time when we were trying out the exercise, while installing Jenkins, it had gone slow. So these are the disadvantages. You will need a lot of memory and CPU, otherwise it goes slow. So this kind of architecture is not uh, very popular or effective in a production environment. If a virtualization software will go slow, then your production applications will be suffering. So these were the problems which did not help continuous integration and delivery process in a good way. We need something fast and something that can be deployed fast. Even for a VM, it takes some time. When you deploy this virtual box, for example, if I create a new virtual image, let me create it because you will need it for doing the Docker installation. So for example, I'm creating a new box. Now this one does not get created very quickly. Like it takes some time. It will take around 1 minute to get up, and then when I boot up it might fail, and then again you reboot and wait for all the updates to happen, because the entire operating system is getting cloned and started. So all these kind of uh, problems are there in the virtual machines. To overcome these problems, Docker was introduced. So Docker is not a virtual machine exactly. It is a platform which packages an application. Here's the definition. I'm just reading that out, then I'll explain. It packages the application and all its dependencies together in form of containers. This containerization aspect of Docker ensures that the application works in any environment. Let's get back to the slide, then I'll give you an example, and then we will discuss the definition again. So for now, you can just imagine, just like we are doing VirtualBox and we are installing something into that VirtualBox, some operating system, and inside it we are installing the uh, application. So similarly, a container, Docker container, is also a box which you can install on a host server, like on a Linux server you can install. Here we will install it inside this virtual box because we don't have a Linux server. But for example, if you are doing it on AWS or Azure or any other cloud instance, so you directly go there, install Docker. So once Docker is there, you can deploy any application on Docker. For example, let's look at these two diagrams. For now, you just put a concept in your mind that Docker is a box inside which I can deploy any one app. I'm telling one. You can deploy more than one, but a good practice is always having one application in one Docker container. That's the way it is designed. People install more than one, but then the real logic behind Docker, gets wasted, because the logic is to make it fast, to make it simple. So you need Jenkins and you are not able to install Jenkins, you can create a Docker container of Jenkins. So only Jenkins will run there and you can deploy it on any server. Another advantage, it helps to isolate our applications. It helps us to maintain the environment. It helps us to create it very quickly. So we'll come to all those advantages. Let's come back here and discuss this diagram and this diagram. So first, looking at this particular diagram. So when you're looking at this one, let's look from the below. Like for example, just imagine we have a hardware. So we have a server on a cloud, or we have a server on premises, or you can imagine your own desktop or laptop computer. So that one is the hardware. So over it, you have a OS. At home, you have this Windows system on running on it. So your laptop, and over it, you have this Windows. Now this Windows have some softwares installed on it. For example, you install this VirtualBox on it, and on VirtualBox you install Linux. So it has its libraries and dependencies there. And on the top of Linux, For example, you have a website which has these three components. These are just different technologies. So there's a website which has a Node.js front end. There is a backend database MongoDB, and there is another tool called Aerospike. So this is just an example. So you have these three applications. You can just take any analogy. Like in Windows, say you have a Notepad++ installed, you have Windows Movie Maker, or you have Windows Media Player, or whatever in your Windows system installed. So all these softwares are on the top of your operating system, sharing many libraries and dependencies. So this is the way in which software was installed and people used to work earlier, before Docker came in. So this was the practice. Operating hardware, OS, then these libraries and dependencies, and all of them will run together. Now, imagine a situation. This particular software is running and being heavily used. And at that time, if someone wants to open this software, it goes slow. But actually, this software is not slow. It is a fast one. But due to the other one, it is getting affected. You might have seen this happen to you many times. Say you are opening a heavy application like Photoshop or something, and at the same time you want to open your browser or check something that is so slow that you have to stop that Photoshop, end it, and then you will be able to again get back your old speed. Or sometimes it gets hung or stuck and you have to reboot your system. So same things happen with the servers also. If you have some software which is heavily traffic heavy, lot of people are trying that website or something, so anything else running on the same server gets affected, because this guy takes all the memory and the CPU, and this guy is left with very little, and there is no way this can be isolated. So this is a big problem. Like if you're running, you cannot just run one thing on one server. You're paying a lot for the servers there in the cloud. So you will have to pay, have to launch multiple things on a particular server. So if there is no isolation of resources or no allocation of resources, then there is a risk that one particular software might take up all the resources, and other softwares running on the same servers will have to suffer. So that is a big problem. So to solve this problem, this concept of Docker has come in. So what we do in Docker, we do not install a virtual box kind of thing and then inside it we install another OS and then deploy our app. We don't do that. In this old scenario, virtual machine scenario, there was hardware OS, virtual machine, this layer, on it another OS like Ubuntu or whatever we are doing here in this case, and on it there will be these apps. But in case of Docker, you don't need that layer. Like this Ubuntu layer is not needed. You install one software called Docker, and on Docker you can run any application you like. And those applications are run from different images. I'll talk about that. We'll slowly go. So now let's revisit what we have spoken. So on a Linux server mostly, Docker is also available on Windows nowadays. So, but we are talking about the server scenario. So let's focus on Linux. So what I am saying, what do we mean by Docker? Docker, you can just imagine it as a box, but don't tell this as a definition when someone asks you on an interview. This is for your understanding. The definition is there on the tutorial which I shared. So go back there and read it up later on. For now, you just understand that Docker is a container or a box which can isolate your softwares. So this box is a Docker container. Inside it, you can keep your one software. Like that's the good practice, as I said. So you can keep one software there, its libraries and dependencies. So this software can be allocated a certain memory, CPU, everything. So this guy will run on its own inside the same server and will not disturb the others. So it will be completely isolated, and Even if it goes slow, it will go slow. These people won't be affected. So these people will run flawlessly. So that way you're saving some resources by isolating things. There are other advantages also. If there is an attack on this container dies. Security attack, like people are trying to hack in, but others won't be affected. I mean, these are just small examples. And most important example is Docker containers can be stored as images and run anywhere. So that is another way to very quickly create environments. For example, what problems do you face when you are doing Jenkins? Like I did Jenkins, it went well. You did it on Windows, it did not go well. Bridge mode is not working. The directly dashboard is coming up. Options are missing. Why this happened? Because the environments didn't match. Mine was maybe on this Mac, and my uh, Docker image, my virtual machine image was different. And the way I installed might be a bit different. What packages were updated in my laptop, that is different from what is there in yours. So these kind of differences cause confusions, where something runs on a particular system might not run on another system. This happens many times. You might have seen in your work experiences, like it's working on the developer's laptop, but it is not working on the server. Or sometimes it's working on the server, but the same code is not working elsewhere. So these kind of discrepancies happen because of the changes in environments or variables, missing libraries or missing dependencies. So it is very difficult to then figure out what is missing and what is causing the error, and then drill down on the problem and make the environments alike, and then only you can move on with your uh, exercises. So that's the problem. So using Docker makes your environment very stable, and you can freeze the environment, and it makes it portable. Like you can carry this container. It's just a small file. Just like I send you videos in MP4 format. So similarly, this Docker would have a image format, Docker image. So these images can be stored on a public repository also, and different people can pull those images and use it on their system. So if I create a Jenkins image on my system and I push it somewhere, you can pull the same Jenkins and run it straight away. You don't have to install or do anything else. I will give you the image, tell you the username and password. You go inside and start using your own Docker. So these Dockers won't be connected to each other, but they are sharing, I mean, they are using the same image. Okay. It's similar to like I give you a CD of Ubuntu, like I give you a CD of Windows 10. I have that image on written on a compact disk, and I installed on my laptop, gave you that image, and handed you that image, and you go and install it on your desktop. So it's similar to that. You can have any software and libraries put into it, make an image, hand it over to anyone you want. That guy can install it on his system, and be it Windows or Linux, doesn't matter, it will run there. So it is so powerful. Like it is containerizing it and not taking anything from the operating system directly. It can run and be able to be deployed anywhere. And because it does not have another operating system on it, so it also saves resources. So here we are only having one OS. In this case, we have one OS. On it, we are installing this virtual box, and inside it, then we are doing this. Or if we are not installing VirtualBox, directly installing the applications, then we are not isolating the resources. So both ways we have problems. Like here, if we do it together, like install directly on the OS, then we have these three sharing the same resource, and one going slow will be responsible for the others going slow. But if I want to isolate using a virtual machine, then isolation will be done, but then problem is I will have to run three other Ubuntu OSs over this OS. So now total I will have 4 operating systems on this server, and it will eventually go slow. But when using Docker, we are containerizing it, means we are creating small boxes which are isolated. These boxes only have the libraries and dependencies. They don't use anything from they don't use anything from each other, and so they are independently working and save a lot of resources. So this is about the what Docker is. It is a software which allows you to isolate your applications. It does not have a nested operating system inside it. It uses the base OS only. It uses the kernel of the base OS to send its signals and speak to the kernel and shell. And that's how it works. But it does not use another operating system to work. So that is what Docker is. Now, we have discussed certain points here that will answer the question like why Docker. So we'll just go through the same concept again. I told you, like, when comparing between virtual machines and Docker, virtual machines are the same like what we are doing in VirtualBox. So here is an example. For example, you have a virtual machine with 7 gigs of memory. Out of that, for example, 4 gigs are being used and 3 gigs are being used by the operating system in the virtual machine. Okay, so in every virtual machine, certain memory, you can say here there is a 4 GB machine, 2 gigs are used by Ubuntu, 2 gigs are used by that application. Here 4 gigs, 1 GB is used by that the operating system, 3 gigs are used by the application running inside it. So what does that mean? So these memories are going waste, because if we have one server on which we have these 3 virtual machines, so we have to again and again allocate these memories for the operating systems, because we are running 3 different operating systems here. For example, like if I start all these 3, so just imagine now this one will say use 2 GB, this one will again use 2 GB, this one. So 3 of them will use 6 gigs already only for running the OS. Now if I go inside and start Jenkins, Jenkins will again use some other memory, say 2 gigs more. So 6 from these 3 and 2 for the Jenkins again. So I have 8 gigs already gone. But imagine if I don't have these OSs, if I could directly only run the Jenkins, then I will only use the 2 gigs instead of all the total which is being consumed for the operating systems. So this is the thing written here. So you can go through this slide also later on and understand the concept. But when you are using Docker, this memory will remain unused because there is no Ubuntu here to eat away that memory. So if it is unused, that's good for the application. Application can have this memory whenever it requires, and it will be faster than this one. So that is why Docker is advantageous. Initially, these concepts like might overwhelm you. If it does, no worries. Just watch this again and again and try to understand what I am saying. The concept is simple. If you have an operating system inside operating system, so you have 2 operating systems now. So more operating system means more memory will be required, more CPU, more resources. So if you are using up more resources, less is left for the application to run. So that application will be slow. Just like we installed Jenkins and it was not very fast, because already we are running Mac OS, we are running Docker, VirtualBox on it, we are running uh, Ubuntu on it, and then very less is left for Jenkins. So Jenkins was going slow. So that's the concept. So that is the reason Docker comes in. It does not use the operating system layer because it is using the host operating system, and that's the reason Docker is making our deployments better. Apart from that, there is another advantage. That is, it isolates things just like VM. So we get that advantage also. So main points are, it's saving resources, allowing us to isolate. Third thing, it is portable. I told you, like, you can, if I run something on my system, I can build an image out of it and send that image to a repo from where you can download and run it on your system. So there is I mean, environments can be replicated on the go very quickly. So no one has to run the installation steps again and again. For example, if I run the commands once in my system and create an image out of it, you don't have to run the commands to install Jenkins. You will just run that image which I sent you. So everything is done automatically. So this is the advantage. Like, for example, you might remember last time we installed Jenkins, say there were 4 or 5 commands to run, and after that Jenkins started working. But here, in case of Docker, you do it once, define the commands in a file which is called the Docker file, and then you deploy it, build an image, send that image to someone else. She will just run that image, so it will work for her. So that is the beauty of Docker. So when we do this, it will make more sense to you. So this is again the same thing has been explained, like what is virtual machine and Docker, and how Docker helps us, and how it will allow to build, ship, and run the container. So these are the benefits which I was talking about. I already told you about the scalable thing of Docker. Like, since it is very easy to run, anyone can just pull an image of Docker and run any number of its versions. For example, any number of replicas. So for example, if my Jenkins is going slow, I can run 2 more Jenkins and send traffic and load balance amongst the 3. So that way, not no single instance will be going slow. So that is the benefit here. That's why it's scalable. Portable, I already told you, one can replicate the environment anywhere else by just sending the image and sharing the image. Then density and deployment. Deployment is very easy, and density here means, like, you can run a lot of containers on the same system together, and uh, they are all isolated, so you don't have the problem of things getting mixed up. And it is agnostic to operating system also. By agnostic, I mean it doesn't care whether you are running it on Windows or Linux. So the same image can be run on any Docker platform, even it will run on the Windows and Linux. But normally other softwares have different binaries. For example, this virtual box is for Mac. If I give you this software and you run it on Windows, it will say it is not a exe file. Or if I take a exe file from Windows and execute it here in this operating system, it will not work. But Docker, once the Docker is installed, then on it you can run the same containers from any platform. So it is platform agnostic, means it is not uh, directly connected to the platform. It doesn't care like what operating system is there in the base system. So these are the advantages. So the same things are also written in our notes here, so go through them, so it will make more sense to you. So here the definition, these are the definitions which you should use when someone asks you. These are the official definitions. So, but to may have an understanding, just remember it's a box which isolates my application that I am running. So that will give you a visual thing of what Docker is. So how that box will be built, how to apply it, that we will do today. So that is our hands-on, like how to install that box, how to put an application inside that box. In simple words, we are going to do these 2 things: installing that box, that framework, and then learning the way we can put our applications on that box. Once these two steps are successful, we'll see how to share that box. Like I have put my Jenkins inside that box, or I have put my that static website application which we did last time. I have put it in the box. Now I will share it with you. So how will I do that? So these are the things we have to do it today. So next thing is certain concepts about Docker. Okay, let me see if there is a slide about that. Okay, before we get into the concepts, here's one more interesting slide which I was talking about. This is about the statistics. Why you are learning Docker and why this will be, this will be very useful for you for the next, at least for the next 5 to 10 years. So these are the numbers, like 65% use Docker to deliver development agility. Like companies, now 65% of the IT companies have started using Docker to speed up their delivery process. Earlier, just imagine if the system is going slow, there are lots of problems. Creating environments is taking a day or two. For example, if someone asks me to install Jenkins, I will spend 1 hour, something goes wrong, port is not working, lots of problems. So figuring out these problems and solving them takes a lot of time. So having Docker makes the development agile, means more faster. Then these 48% used to control application environments. Like you remember that CI/CD pipeline I was talking, like we have development, staging, test, prod environments. So creating that environments would normally take a lot of time. Like for example, someone asked me to install Java for his Java application. So we will go and in downloads Java 8, like we did the other day. We did a curl command and got the Java 8, open the package, install it, update it, and then it is ready. So all these steps happen. So when you want to avoid these steps, you can create Docker images. That is only a one-time work. In Docker, writing a Docker image and creating it is a one-time hard work. Like once you do it, then 50 environments, 100 environments, 1,000 environments you can build with your own Docker files. So you don't have to build the environments again and again. So you are saving time. So these are the advantages. So almost more than half of the industry has started adopting it. Then about 50%. So those who have not will slowly now see the others going faster and they will also adopt. So when they adopt Docker, those people who know about Docker will get jobs and their demand will be increasing. So that's the reason we are learning it, because there is still a lot of people who are not using it. They will start using it and they will start hiring people like us. And then 41% use Docker to achieve portability. Like there are many software companies who want their applications to be portable to, because their teams are distributed. So maybe there are some companies where one team is in different continent and another is somewhere else. So they would like to have a very quick way to replicate their environments across different offices and so on. So if you are doing it manually using a Linux system admin, he will go and install the same thing there on the new site. So this is not very effective and uh, people lose a lot of money there. So that's why Docker helps you to make it portable. So like build something somewhere, port it to the other place. By porting, we mean we will put that thing on a public repo or on another private repo accessible to the other office. So that office people will run the commands to pull this container from there and use it on their office and build the same environments. So it helps to quickly replicate the environments. Apart from that, it 90% use Docker for apps in development. In development environment, it helps a lot because there are lots of errors in development environment. So for example, you are working on developing Jenkins software. So you made some program and the Jenkins has crashed. So if it is a normal development environment, you will have to figure out what mistake you made, then fix it, then solve it. But if you are using Docker, you just delete that Docker, launch a new one, and again start working. So you don't have to fix that error. Instead, you can start working fresh because you know what you did last time. So don't go that direction and do something else. So it is normally for developers, not for us. So I'm just saying, like, it helps developers if they use Docker in the development environment. It is easy for them to throw away their work. Like something goes wrong, just destroy that instance, create another Docker, because Docker takes seconds to launch. Like when I'll do it, you will see, like if I run a Jenkins, it will run in 5 seconds. But here I'm not saying it is very slow. It might take minutes in the virtual machines. And if you do it on a bare metal, then it is even more. It will take an hour to set up the operating system, then install Jenkins. So that way, Docker gets you on your feet very fast. Like in 5-10 seconds, entire thing is back up. So people don't realize that something was down. So that's the reason big websites, like for example Google, Facebook, these have outages, but they are so minuscule, like for such a short interval that you don't even realize when it went down. And apart from that, apart from using containers, they also have lots of other strategies. Like they will have load balancers, multiple servers, multiple containers running. So lots of things go in there. But I'm just saying they use containers to achieve this fast. Like something goes down, very quickly they can achieve um, or recover back from their problems. So these are the stats. You can go through them, like which companies, what is the breakup, and what percentage of web application companies are using most. API companies are using 75%, and so on. So where Docker is used, why it is used, and so on. 80% of companies who practice DevOps use Docker. So most DevOps using companies are using Docker. So that's why Docker is in demand, and you should learn it very well, because that will become a strength. Docker and Jenkins, these are very two important things. And Git and all, it's there. You have to know the commands and all. You have to do it anyways. But these two will almost encompass 50% of your work. Rest of the things you can take your time and learn. Okay, moving on. Let's now start doing the Docker installation, and then we will start using Docker. Okay, so first let me show you one. Let me go into the Ubuntu operating system. Then I'll show you how to install Docker. Don't worry about the commands, it's already there in that tutorial. If something doesn't work or we change something, we will edit the tutorial there directly. So that way you will be able to do it. Okay, so let me go back to the VirtualBox. So we had launched a new VirtualBox called Docker from that same base image. You can do the same thing because this Jenkins one was going slow, so I didn't do it there. You can do it on the old one also, because Docker doesn't take up too much memory or anything. It won't hang the system. Okay, so it's running. What I will do, I'll just check the IP address of this system and then log in through the terminal. So the IP address here is 192.168.0.100. This line you can see here. So I'll go to the terminal. If in Windows, you will do it on putty. The user is DevOps @ 192.168.0.100. I think towards the end of all these sessions, I will also create one session where I will demonstrate how to launch a instance in AWS, and I will also show you how to use putty to log into that instance. So that will help you, because I haven't shown that. That is not actually a part of anything to do with DevOps, but just for your understanding, we'll create that video also. Okay, so here I am putting up the password. So I'm logged into that DevOps Linux server. So first command would be, normally I do everything as root because I normally will have to do the installations. You can do it either as root, or you can write sudo before every command. That also works. So whichever you are comfortable with, you can do it. And even if you are as root and you are writing sudo, no problem, like it works, but not a good practice. It's a good practice to write sudo on every command and do it, but if you are confident to do it as root, you can. Okay, so first task will be to install the Docker, because if now I write anything Docker, it will say command not found. Okay, so we don't have Docker installed here. So how to install Docker, that is one thing. And another thing is, sometimes there are servers where older versions of Docker are already there. So you might want to remove them and install them. Okay. So if you want to remove them, then you can write a apt remove command and remove them. I have put it there on the tutorial also, I think. Okay, installation I haven't put it. Just a moment. Let's add that as well, so that, okay, here I haven't committed it. So this is the command which you will use to remove the Docker if it is already there. So first remove to clear it, and then we will install the new version. But in our case, this is a new server, so we don't have to run this command. Understood? Okay, so let me push this. So that you will get it on the repository. So see, I am doing the same thing which we did in Git. So I did git add, this stage means add. Then I wrote a comment to commit, git commit -m, then this comment, commit. So this same thing is happening in GUI. Add commit is done, now I will push. So Atom has a Git plugin. If you install that plugin, Atom preferences, then install plugin, then install a Git plugin, you will get this thing on your right hand side, and you can also use it. But I recommend you use the commands for some time so that you remember them. Okay, so this is gone. So this thing would be added here. If we refresh the page, it will be there. So we have this install Docker now. Okay, so first command is already done. So why I'm doing it from here, so that we will also verify there is any spelling mistake or anything or not, so that if you copy these commands, it will work for you. That's why I put it here, and then I'll use the same command. So we will immediately know if there is some mistake in this command, then it will fail here and we will fix it. So no plugin there was nothing there. So we are good. This is only for checking if there is Docker already, removing it to install. Production system, don't do it. Just if someone has asked you to do it, to remove the old Docker and install, only then. If you are doing it on a new system, we are doing this just for double checking. Otherwise, this command is sufficient to install Docker. apt install docker.io for Ubuntu. For other flavors of Linux, there are different other installation commands. Let me also show you those. So if you want to install Docker, these commands keep on changing. Wait, Docker install official. There are lots. You can choose any platform, for example, Linux. Then it is saying which Linux. We did for Ubuntu, so we have already checked this. For example, if you are doing on any other Linux, CentOS, then here is the command uninstall and the install. So always follow the official repository to do that. Okay, and even I am following the official repository. Why? Because these paths keep on changing. Like whenever they apply new versions, sometimes they change these paths. So if you get uh, if you are using a path which is old, then you will get an older version of Docker. So always follow the official Docker documents to install. For learning purpose, you can just use this shortcut command. So this also installs the latest Docker, but only works in Ubuntu. It will not work in CentOS Linux. Okay. So going back to our installation. So apt install docker.io. It tries to install, asking yes or no. Yes. So now the installation will happen. Once the installation happens, I'll tell you a few concepts about Docker, and then once you and show you some commands on Docker, basic commands. When you see what's going on, then we will try to create one Docker image, run the one application there, and we will try to also host that website code which we have in the repo using Docker. Okay, so let's see how to do these tasks, because this creating Docker image concept will help you a lot when you will do the pipeline and deployment. So creating an image, running an image, these two are important things to learn from now on. So let Docker install, we'll see what commands are available and how to do these two tasks. Okay, it is installing different libraries for Docker. So once it is done, we are back in the prompt. So I'm clearing the screen, Control L. Okay, once Docker is installed, you can check Docker service is running or not using this command, service Docker status. Okay, so here Docker socket and all that is showing up. It says that Docker is inactive. So we can start it. So now it says Docker is running. So we are good. Now that Docker is running, we can start using Docker commands. So these commands are, so this installation part is done now. Let me see if we have some commands here. No, here there are some concepts. We'll come to that. Let's run a few commands and uh, just to show you around what it means to install Docker. So Docker is installed. First command you would try is that command service status and service start if it is not started already. In some distributions of Linux, if you install Docker, the service is in a started state. So that's why we are running this status to see if it is running or not. Okay. So that step is done. Then you do a Docker PS. It shows if there is any Docker container running from any image, anything is going on or not. Now you don't see anything. You see container ID, image, command created, status, and so on. So what does these things mean? and you don't see anything under this table. Like container ID, under it you don't see any ID. Image, under it you don't see any image ID. Command, you don't see any command. It's blank. That means it's a new Docker server. There's nothing running there. Now, what are these tabs? Like, what does they mean? What do they mean? So let's try to understand those concepts. For that, let's go back to the slide. So let's look at this picture first. You are the user. You are talking to Docker using what? Using the Docker CLI. This one is the Docker CLI. I am running commands with, I'm talking to Docker, like I am writing Docker images. These are different commands. I'll teach you what they are. And it gives me this, that there is no image. I'm writing Docker PS for the process listing of Docker. It is saying that these are the headings, but there is nothing. So how am I talking to Docker? I'm talking it through a command line interface. So the user talks to Docker using a command line. So that's the thing, like you have to understand. So how will you interact with Docker? Using some commands. Then when the user writes those commands, this command goes to the Docker daemon. Daemon in Linux means a background process. So I showed you this status command. What does it say? That there is a service that is running. So there is a daemon that is running in the background. That daemon is called Docker D. Docker D stands for Docker daemon. Okay. So a background process is running that will listen to my commands. So when I'm writing Docker images or Docker PS, any Docker command, so this guy in the background is listening to me and he will give the response if there is something there running in the Docker or not. Whatever I ask, I will create an image, I will run an image, I will do whatever. I will ask using the CLI, and this guy is the one who is working. Now, just for your knowledge, like no need to go this deep. This guy again talks to another process inside. Okay, that process is called run C. Run C. Run C runs the containers. So when you run a container, when I say Docker, these are various commands. You will have to remember them initially. Docker run, these are commands interactively, and I name something like say Jenkins. Say I want to run Jenkins and I am running this command. Then when I execute this command will go to Docker D, the daemon in the background, and tell that, see, this is what you have to do. Now this guy will tell another process called run C to run the Jenkins container. Then that run C process will look for whether there is a container image there in that server or not, or it will do something to bring that. So we'll come to that again. So now, for now, you just remember this part. User writes commands on the CLI command line interface, writes Docker commands. That is listened to by the Docker daemon. Docker daemon talks to container D. I mean, both are same essentially, but I'm just saying the container D talks to run C, and then the process is executed. So this is how it happens. Like many background processes are working together, container D, run C, and the daemon. So daemon is the background process which is controlling Docker D and run C. So those three. So these are, I mean, when you're working, you won't need these concepts. These concepts are for your knowledge and for talking to people about Docker for your interviews. Like if someone asks you a question, so when you are running a Docker, what is going on behind the scenes? So you can tell, like when I'm writing a command, I'm writing it on a CLI. So it is actually being taken by a Docker daemon process, which is running. That's why I started the Docker service, because I stopped the Docker service and you will see no one will respond to my command. Let me show you that also. I will stop this. So what does that mean? Status is inactive. Okay, status is dead. So that means this guy has exited. Docker D is container D is not running anymore. So now if I do a Docker command, any Docker command, Docker PS, it says cannot talk to this container. Is the daemon running? That means this guy can only respond. It's not like any other Linux command. This, for example, in Linux, I write ls. I can always see the stuff, what is there. But Docker command will only run when the Docker process is in a started state. So I'll just start it again. And if I do a Docker PS, now it is responding. So that is the concept behind it. Now let's go through some terminologies. What is a container? What is the image? What is a registry? What is a volume? And what is a network? Volumes and networks, you won't need it much at this stage, but I'll tell you what they are. But these are the three things that will come again and again. First two are very important, like container and images. Important for your interviews, important for working with Docker. Okay, so let's go back to our tutorial, because there is a diagram there which will explain you certain concept. This one. Okay, so when now you know that Docker is a box that will encapsulate your application. For example, if you are running Jenkins, the Docker will encapsulate that Jenkins and run it for you. Or if you're running any other server, the Docker will encapsulate that particular thing to run it for you. So this concept you know by now. Now, how that Jenkins is built. Okay, so we have a file called Docker file, inside which we have some code written how to build Jenkins. It will contain those commands um, which we actually run while installing Jenkins. So that Docker file will be used to build a Docker image, and when you run that Docker image, it becomes a Docker container. Okay, so now it wouldn't make much sense to you, because this is the first time you're listening to this thing. So let's do this thing reverse. Like, we will run one Docker container and I will show you what the image is, and then we'll go and open that image and see what is inside. So we'll reverse engineer these things. So first of all, let's run something on Docker. Okay, so let's run, what do we run? Let's run a simple service. Let's run Jenkins. Okay, that brings you to another important thing that's called Docker Hub. Just like you have GitHub for code files, you have Docker Hub for Docker images and all that stuff. For example, I'll try to run Jenkins on Docker. So I search Jenkins, and there are so many Jenkins images here. So what does that mean? That means many people have built their own Jenkins and kept it here. So we'll use the official Jenkins. Okay, so it says this is the official Jenkins, and this is how you can run that Jenkins server. Okay, that's good. So first step for installing this Jenkins is to do Docker pull Jenkins. That will pull the image from this repo. These are all public images. They won't need any authentication. So Docker pull Jenkins. These commands are all there in the this tutorial as well as being recorded here as I do it. So no worries, you can just see what I am doing, and later on when you watch this couple of times, it will make very good understanding to you. Okay, so Docker pull Jenkins will pull the Jenkins image from Docker Hub to your server wherever you are installing. So here you will see how fast the Jenkins gets installed. Okay, we had some network issue, so let's do that again, no worries. In Docker, all these things are so exciting. Like you see, there was a network issue, and only thing you have to do is run that command again. So it will try to resume it from there itself. It did not download whatever was already done, then it tried to resume it from there. And you can run this command again and again. Now, why this network fails and all, this depends on your laptop or your internet. So the Docker guys don't have anything to do with this. And this image is very big, Jenkins, so that's why it takes time. But I was trying to show you Jenkins because you know about it. But otherwise, we could run any other application. Like you can run Apache, web server, Nginx, MySQL database, anything you can run on Docker. And very quickly it will launch the instance. Let's do Jenkins, like doesn't harm. We'll just start it and then stop it. So just to see that how quick we can do it. So first command was Docker pull Jenkins. And once the Jenkins is pulled, here you can see what command to use this image. So it's all simple. So if we run this command, we will be running the Jenkins server on this particular port. I'll discuss all the options when we come to that. First, we'll discuss the basic commands, then I'll tell you what we did and why we wrote like this, why -p, what is the meaning of 8080 here and 8080 here. So we'll discuss all that. And these are various other uh, variations of this same command. We don't have to run all the commands. We just have to run this command. So I am copying this command, and let's see how far we have gone. So it's still pulling the Jenkins image. This is only a one-time requirement, this pull. If we pull this once and next time someone tries to install Jenkins on this server, then he will be able to do it in a few seconds. So that's why we say like Docker can launch everything in a couple of seconds, because you are able to quickly pull the image. Once it is done, it already caches the image. So it stores the image in different layers. These are called layers. So once you store the layers in your system, it will not pull it again. Only the changes, new changes, say Jenkins version 2.0 comes up and you run Jenkins again tomorrow, so it will only pull the new uh, changes, only the differential changes, not the entire image. So that's why tomorrow if I run it, uh, I'll be able to run it in a couple of seconds instead of waiting, because once we have waited and downloaded the image, it stays there. Okay, now the image is being extracted and so on. So once this pull process is complete, we are ready to go ahead and launch the Jenkins. So this command docker run, docker pull is pulling it from the repo. Docker run will run the image. What did we do with docker pull? We pulled the image, but when we run the image, it will create a container out of it. Okay. So let's see what happens. You see, we are at that step. you will remember this step well. This is that password that we have to put on the Jenkins initially. So it's done. So you saw how fast it is when you are doing it on a container. So what we can do here is 192.168.0.100 is my IP, today's virtual machine IP, 8080. So now it will take us to this Jenkins. So just put that password, copy it from the terminal like I did, and continue, and then you are done. Now that plugin installation page will come and you will install it. So using Docker, it is even more simpler. Okay. All right. So if you wait, this one will come. I click this, all the plugins will be installed, and then I get the dashboard. I think in your case, somehow this stage got cancelled. And if I cross this over, then also if I do it next time, I'll get the dashboard, but then I have to install the plugins manually. So we are not getting into this today. We'll again do the Jenkins thing. We will focus on the Docker. So you saw how quickly we were able to install the Jenkins in 15 seconds. I mean, apart from pulling the image, because that's a one-time thing. You anyways, when you are installing any software, once you will download it anyway. But for preparing and running it, you take time. So that's where Docker helps you to minimize that timing. So I'm just doing a Control C to shut down. And now if I do Docker PS, I don't see anything because the Jenkins is dead. It's shut down. But if I want to see whether Jenkins was running earlier or not, I can write Docker PS -a that shows all instances active and non-active. So here you see container ID this Jenkins. There was some command running inside Jenkins in the background 2 minutes ago, exited, and all the states. Ports are not showing because it's dead now. So when Jenkins was running, if someone runs a Docker PS, he will see this Jenkins running here. So that's how the Docker PS commands works. So you know what a Docker PS command is. I have it here. All of that is there. If not, we'll add it. Yeah, it's there. So if you do a Docker PS, you do a list of you see a list of running containers. If you do a PS -a, you see all the containers, both running and those that have been stopped. I will show you all the common commands here, but for your learning, I have written all the commands here, like different commands. Some of them you won't even need normally for your operation, but let it be here in this tutorial. You can try these commands, all of them. But for general operation, you will need Docker PS to see there is any Docker running or not. PS -a if there was something running but now stopped. So you can see that also. If you want to clear that container, Docker RM means remove -f forcefully that ID. If I do this, it removes the Jenkins and clears my system. Now if I do Docker PS -a, there is nothing. So I have cleared the system, so I can run it anything else again. Even if you don't remove, nothing will happen. It will just remain there. Okay. But it is a good practice. If something is dead already and you're not using it, you can remove it. And if you don't want to remove it, you can run the same thing again. Like for example, if this Jenkins was dead and I did not remove it, I could relaunch it by Docker start and then that ID. Then that would have started the Docker, but now I have removed it, so it will not find this ID and give an error. because that ID is not there. But next time I'll run something else, stop it and show you this start command, so that you will see that it is in exited state, but when you start it, you can launch the same container. Because you might be thinking, what happens when I stop the server and go away, and next day I come and start and my Jenkins is gone? So that will not happen. You can stop it, and then next time you launch your Linux, you can start your Jenkins again. But in production server, you normally won't need it, because there the servers will run 24/7 and you don't have to stop it ever. Okay. So docker ps -a docker run is for running any uh, image. Then let me discuss a bit more about these flags. -p means port. This is the port in which this VM will listen. This is the port in which outside people will see that page. So in both cases, we are putting 8080. So whenever we write on the browser from outside, we will put 8080. So internally inside the Docker also, it will run on 8080. Why it is given? In some places, you can change this. Like I will run Jenkins inside 8080, but outside I can make 8888 or something like that, so that browser guys can open with 8888, but inside Jenkins will be running on 8080. Why this is done? There are certain servers where certain ports are already used. Like for example, if I have Apache Tomcat running on a server, it also uses 8080. So if I use the Jenkins on the same server, so there will be a conflict because both will want the same port. So in those cases, I have to change this port number. So that's why this option is there. Even if you don't write this, it will run on any port it likes. So that's why we are defining the port. Similarly, this is another port for the secure interface of Jenkins. We are not using that. So that's the 50,000 port. We won't need that. But since it was there in the official command, that's why we had to put it here. So this is about how the Docker run command is working. Now, remember we pulled the image using Docker pull, and the name of the image was Jenkins. So we did this and it tried to pull the image. Now it will also try and it will see that it's already there. So it's up to date. So it doesn't need to pull it again. Now where does it store the image and how will I see that image? So there comes the command docker images. So here earlier this was showing blank, right? Now you can see there is an image called Jenkins. It was created by that company 22 months ago. Its size is this much and it's latest and it's working. I mean, this is the image. Similarly, images can also be deleted. Say tomorrow there is a new Jenkins and I want to remove this old one and again want to pull the new version. So I can also do docker rmi -f and the name or ID of the image. Which one? I normally use the IDs because there can be multiple images with the same name. Tag and IDs will be different. So then you might confuse. So that's why if you use the ID to delete anything, then you really know which one you're deleting is correct. So if I delete this, then this image will go away, and if I do Docker images, again it will be blank, but I'm not deleting it, let it be. So that is the first couple of commands that we ran. There are some other commands, we'll come to it once we do something. I mean, once we do something useful. Now we build our own image and run it, and then we'll run those commands like start, stop, and how to resume a stopped container, how to store our image, and so on. So let's do that. Let me go back to the Okay, so let's go back to that same diagram again. Now it will make some sense to you. We know that there is a Docker image which we pulled, Jenkins, Docker pull Jenkins. That image came to my computer server and stored there. And then when I do a Docker run Jenkins with the port and all, then it started running. So when a Docker image runs, it is called a container, because that is where we are using that software which is inside that box or the container. So image is just the image which is not running, and this is actually the instance which is running. So if you are a programmer, you can also think of that this is the class and this is the instance. But now, for now, you can just see image is a template. You can pull it from an external repo and you can run it so that you get a running container. Now we go to one step behind, like how this image was built. Like this guy Jenkins has built this image and stored it somewhere. So how did this guy build this Jenkins image? Can we build images also? So the answer is yes. We can build our own images. We can also store them. Okay. So how to do that? So we'll do this exercise. So for that, let's go to our repository. Here, what I have done, I have created a repository called static site Docker. I'm not showing how I created because we already know how to create repo in GitHub and all. So what I did, I created a new repo, static site Docker, for this exercise, and I copied all the code from this into a folder and put it there. I'm showing you like how I did, what I did. This HTML is the folder where I have my code. This code is that example website code which we did other day. Okay, so this has some code which our developer had given us. So we have put that code in a folder called HTML, and that is here. Now, along with this, we have added two extra files. One is called the Docker file and another one is called the wrapper.sh. This is a script to run this entire show, and Docker file defines how to deploy this website into a web server. So let me show you what is inside this file. There are many types of Docker files, like contents will change everywhere. So we'll discuss all that gradually. So for now, for a website, static website, you remember this is the Docker file to use. So you will not normally have to write all this code. So these Docker files are they're available from the Docker Hub. Many people have done these things already. And sometimes you have to just tweak certain things. So I got a Docker file for running Nginx. Nginx is a web server. You can search this in the Google and know more about it. Nginx and Apache are web servers. You can search Nginx. I'm writing this just so that it gets captured in the video. And Apache. Search about these things. These are two different web servers, do the same task. Like you can either use Nginx, you can either use Apache. It's up to you. So whichever web server you use, your code will be deployed using that. The task is to run your code so that it is viewable from a browser. So we are using Nginx as a web server to host our code. So that's all. So we have certain definitions in this Docker file where what we are telling that you use the base image called Nginx. So we are writing from Nginx means base image will be from Nginx web server. Copy this wrapper.sh, like this script, copy it into that Docker file. Copy it into that Docker image which you built. Copy this HTML folder which has our code into this location, because Nginx works from this location. and then run this script. So this is our simple Docker file. Okay. So we add this file here and we add the script here. The script will just start the Nginx daemon or the background service. So once this is ready, so what you will do, you will create one repo like this for your practice also in your own repository. Then you will copy your own path, this one, and go to your server. Now what I am trying to do, I am trying to build my own image. I am not going to pull anything from Docker Hub. Why? Because this website is my simple, this is our own code our developer has given us. So we are putting it in this HTML folder, and we won't find this image in Docker Hub because this is not public. This is our code our developer has developed and he wants us to deploy it. So we create our own Docker file, we add the wrapper script, and then we try to start deploying it. So first step, create your repo, put your code there, put your Docker file and script, and then you run a git clone command. Now today we are doing all this manually. When we move on to the Jenkins again, we will automate these steps only. So that's why knowing these steps is important. So git clone will bring that code to my system. Now I have this static Docker site here, cd this. So I go inside that folder. Now I can see that HTML is there, this is there, Docker file is there. Now as per our tutorial, Docker file can be built used to a Docker image, and then Docker image can be run to a Docker container. Okay, so let's first do this step. How to build a Docker file to build a Docker image. Let's see. So the command is docker build -t is for the tag. Sometimes people write like this also. Both of it works. Then you name the image. Tag means the name of the image. So for example, you can name anything actually. It's up to you. But normally people do it company name or whatever, and then slash image name. So our website is called static site, and then colon version v1.0. Some people write just 1.0. So whatever is your norm, you can write. You can also just write one name, like it's not compulsory to write the entire thing. You remember Jenkins? It was just like this, Jenkins. Or so we can just write static website or whatever. But always follow the good practice: company name, software name, version number. Okay, and dot. This dot means all the files are available in the current folder. This current folder is dot. So this is the command. It's there in the tutorial also, but follow this video and do it so that it will succeed. So it's trying to build the image. Last time we didn't build the image because we had a ready-made image in Docker Hub and we used it. Now we are building our own custom website. Our own company developers has given us code. I took the code, put it on a HTML folder, created a repository, put all these scripts there, only these two files. So wherever there will be a deployment, you will have to add one or two files of your own. So for each kind of project, I will give you some samples. So don't worry. HTML, static website, these two. Java, I will give you some files. For others, I will give you like Python, and there are other files also for building those images. Okay, so successfully tagged the Binpipe this image. So we have a image ready. We can verify with this command. Docker images, remember, it will show the list. Now it has 3 images here. One is that Jenkins one, which we did earlier. Nginx, why? Because in order to build this image, it needed a layer. It needed Nginx server. So it pulled Nginx also. So that's why. And this is the image we are talking about. So this is our image with our website. Now let's try to start running our website. Okay. So the command is there here. If not, then I'll write it down. These are the basic commands. There are lots of commands which are not necessary also, but I just kept it here. You also keep it, like someday it might come useful, like commands like this one, image ls. No one does that because we are just doing Docker images. Similarly, Docker diff, this shows difference between two containers, like what is there in that container or what is not there in this container. So these kind of things, like, very less needed. But whatever commands I am running, just follow those because those are always needed. Building images, Docker ps, Docker run, Docker remove. So these are the day-to-day activities: removing containers, adding containers, building new ones. Okay. Now, so we have done this step. This version and all, forget it. Like, if you want, you can name it. You can name v 1.0, whatever you did that, then it will work that way. Okay. And then you can run this command to launch it. You can run 80 both sides. You can run one of them on 8888 and internally on 80, whatever you like. So I am just writing this just to demonstrate you how it is running on a different port. By default, web servers run on port 80. You also remember this fact. Web servers run on port 80, HTTP protocol is on 80, HTTPS is on 443. So sometimes they ask on the interviews, what is the port number for HTTP or things like that. These are more covered in system administration courses where you learn about Apache servers and all that. Okay, coming back to Docker. So here, this command will allow us to run our Docker image. Sorry, why it isn't running? Because our image name is different. Our name is this colon, our tag is v 1.0. This one was different. Okay, so whatever you do while building, use that name here. Name doesn't matter. So now Docker run -p is the port and this. I will add one more step here, like one more switch, that is -d. If you add this, then it runs the Docker on a background. So that helps to free your shell. Shell in the sense, it brings your prompt back to the next stage so that you can run other commands and see. So always when you're using Docker run, try to add this D. If you don't add D, it will be running, like the logs will be coming here only, like we did for Jenkins. Okay. So, but in those cases, I had to stop it using Control C, remember? So here it's different. -d means it will take it to the background. It will run the Docker image as a daemon. So, okay, we got an error that wrapper.sh had a permission denied. All right. So let's try to fix that error and try to build it again. Okay. It's good that, because these are workshops, so it's good that we see certain errors here and we will try to fix it, so that will, whenever you face these errors, you will also be able to fix. So what do we see from this error? Permission denied on this script. So that's why this script was not running. So let's do a ls and see what are the permissions for this file. In Linux, this R means read, W means write, and if there is a X here, that means execute. Okay, so that means you can write the file, read the file, and execute the file. If it is a script, you need a executable permission. So we forgot to provide the permission of execute to this file. So that's why it is failing. So let's run this command. Plus X means I want to add the execute to this file. So you do this and then run the build command again. Because we made some changes, we have to again build it. So now you saw it built in minutes, in seconds. Because everything was already there, it only had to add one command. So let me clear screen and let's run it again. Now the build is there. So let's run it again. If everything will be fine, now it will run. Otherwise it will show another error which we have to fix. So now you can see one ID came and it went away. So that means the Docker is running fine. We can verify using Docker PS. It will show if something is running. So it says 10 seconds ago it's running. So we go back to our IP address. What is the IP of this server? Where is it? Okay, this one. And port is 8888 or 80. So we'll try from the browser. See, we got our website. So this is the website that was there. Binpipe static website. It depends upon what the code is. So it was just I took a sample of a cartoon website and put it here. So we have our website ready and it's working. So what does this mean? This means that this is how, say for example, this is a running application which will be provided by your development team. Then you can just create a Docker container and deploy it. So in seconds, we were able to deploy this application. See, the one-time fixes and all that is to be done only once, right? For now, you know the commands, you know whatever is there. Now, if we fit these commands into the Jenkins pipelines, so from the next time, it will quickly deploy, remove, and so on. So that is how we do this. I would ask you to, like, next time when you are following this video, do all these steps again and again to get a hold on what I was trying to do. Like, first, let me reiterate the major steps. First, there was a repo in GitHub where I created a new repo, created a folder called HTML, put the code that was given by the web development team into that HTML folder. Then I added two files, Docker file and wrapper.sh. Third step, committed all that. Then git clone, bring it to the server. Once it is on the server, do that step, chmod plus x, which we had forgotten. So let me add that step to your this one. Install Docker to the tutorial so that you will be able to do it. Git clone, cd this, then chmod plus x wrapper.sh. Okay, and then we built it, then we run it. That's it. And 8888 port, it is there. You can even use 80. but just to demonstrate, it can run on other ports also. I'm showing. If you use 80, you don't have to give anything. You just write IP address on the browser and it will show up there. Okay, so added this. So this is the comment. So once we save this file, stage it, then we commit it and we push it. So it goes to the tutorial file and you will be able to see it. All right, so the first task is done. There were some more tasks also. Let's quickly cover it. Like it will take 15 minutes more, I think, because let's have it in one video. You can watch it at your ease. So next is what is a registry? Registry means whenever your images are stored on a public place like Docker Hub, that is called a registry. Like you are storing it on a central location, that is called a registry. Then what is a volume? Volume means if you are attaching a disk to Docker, that is also possible. Now your Docker file and everything is put into a container and it is working, but you can also attach external disks to your container. So we will do that in due course. So that is called a volume. Volume means external disks that are attached to your containers. Network, your Docker has its own network and IP address, Docker container. So that Docker engine IP, which different containers use to talk to each other, is called the Docker network. Okay, I'm showing you one thing in the server. You see, this L0 was already there. This IP address was also there. Today, after installing Docker, we got these two. This one and this one. So this is a virtual Ethernet adapter. We don't need it. This particular one is of importance. Like when you install Docker, Docker has its own IP address range, own network. So that is the Docker network. So when Docker container talks to another Docker container, it talks over these IP addresses. It does not use the outside IP. So that is the Docker network. So we don't have to actually do anything in this. This one happens automatically when you install Docker. So, but just for the knowledge, like Docker has these components: containers, images, registry, volumes, and the network. Then these are some information which will help you understand. Like these commands are already there in your tutorial notes, but this diagram will help you understand the life cycle of Docker. When a Docker is created, it stays as an image. When you start an image, it goes to a running state. Then from running, you can run Docker stop to stop it. You can run Docker pause to pause it, and you can even kill Docker rm command to kill it. So this is the life cycle. Like a stopped container can be restarted, paused container can be unpaused, means started, running container can be killed, and so on. Like a paused container can be removed also, and these kind of things, like what can happen at what state. So these are the different states at which the Docker container is, and these are the different common commands. We use this one to pull, sorry, and we use this one uh, to show the images, this one to build, but these are not complete commands, so better follow the tutorial commands from there. Run will allow you to run. Docker commit can allow you to create a image from another image. These are less needed, so I've just listed it here, but you won't need it. Docker ps is for listing. Stop will stop a image. Rm will remove a image. Rmi remove a container, and rmi will remove a image. Let me show you the stop thing, which we missed out last time because Jenkins was already removed, so we could not stop it. Now you see our website is up and running. This one is our container. So our website is here. Okay, it's running. Now, if I want to stop the website for a while, so we can write this command docker stop, or I want to stop this VM or something. So I can just write docker stop and the ID. So if I do a docker ps, there's nothing. And if I do a docker ps minus a, it says that the image has been stopped, exited. So now if I go to the website, it will be down. So because I have stopped it. And you can resume using start. Same ID and start. Now your website will be up. So you see how quickly 1 second site is down, 1 second site is up. So that is how fast it is. If this were a normal website or a web application running on some server, you cannot bring it back in 1 second. I mean, less than 1 second. You have to bring the code back, you have to run Apache or Nginx there, you have to restart the service and all that stuff. But here it allows you to very quickly deploy, I mean, retain the original state or deploy a new version and so on. So that is how powerful Docker is. Okay, so that tells us about the, are you able to see the screen?
No.
Yeah, I'm sorry.
Yeah, that's okay.
Whenever I by mistake click this now, yes,
Yeah, now I can see.
okay. Whenever I click that zoom icon by mistake, it stops recording. All right, so wait, let me move this one away. Now finally, this brings to this topic. This one you don't need to put into a brain now. I'm just telling you, but you can read about these things later because this will overwhelm you. I'm just telling you the background of this orchestrators because this is not covered in this course, but you should have an idea so that in future you will think, okay, this was what I was being told for the advanced versions of Docker course. Like when this is one Docker container we are running now. For example, this website, remember we just built our own Docker container and ran it. Before that, we built our own Jenkins server and ran it, and we pulled it. Sorry, we didn't build it. We pulled it from a public repo and ran it. But these were all single instances. Just imagine a company like Google or Amazon. They would be having hundreds or thousands of Docker containers because so many people are logging into their website. For sure, that would not be running on one Docker. Okay, because our website ran on one Docker because we have one traffic, like only I am watching it or two of us are watching it. But if there are hundreds, then our Docker container will get killed. So to serve that traffic, we have to have multiple Docker containers. Like now only one container is running, then we would have 10 or 12 or 15 or more containers. So if you have so many containers running, don't you think it would be very difficult to manage all this? Because say you have 100 containers running, you would not have 100 containers on a single server. You would have 50 servers over which on each server two containers are running and so on to have 100 containers in the cluster. So if this thing happens, so is it possible for someone to manage 50 servers with 100 containers? All containers are running on different ports, and managing all that is very difficult. So in order to managing the network, the communication, security, everything, it will become very difficult and confusing. So in order to solve these kind of problems, we use tools called container orchestrators. Now there are many kinds of container orchestrators. There is a simple orchestrator called Docker Compose that I'll demonstrate you in one forthcoming session. But there are some advanced orchestrators also. For now, you just know their names because being a DevOps person, you should at least know about them. But later on, when you are confident with basic DevOps stuff, which is covered in this course, then later on you can try mastering one of them, then move on to the next. And the more you learn, that will be better. Even I do not know all of them. I have used this Kubernetes, Marathon, and ECS till now, and Swarm earlier I had used. Rest of the things, I have worked in companies where they do not use this, so I could not manage to learn this yet. But yes, the concepts are same. So if you give me these tools, maybe I'll learn it very quickly. So at least you learn one or two later on. So whenever, because you never know your company would be using which tool, which cloud they are on. So commonly most people use Amazon, so ECS is a good choice of orchestrator. Kubernetes is very popular, so people learn this. If your company is a very big company having millions of customers like Twitter and all, they use Mesos Marathon orchestrator. And Docker Swarm mostly not used in production. No need to, I mean, I would not recommend learning it. You can watch some videos and get a hang of it. Mostly I haven't seen this ever used in production systems, so that's fine. Core OS also not very popular. This Cloud Foundry is also out of vogue now. So Azure, GCP, ECS, Kubernetes, Marathon, these are good contenders for orchestrators. Now what do orchestrator do? Definition is there on the tutorial page, the notes page, but but in simple words, container orchestrator manages the Docker images across multiple instances in a cluster. So if you have hundreds of Docker images, then that will be managed using these container orchestrators. Okay, so there is a web interface, there is a CLI again for this orchestrator. So once you use this, you don't have to run the Docker commands. So what will happen? Say you have to run a Docker image, you will run ECS commands or Kubernetes commands. In the background, they will call the Docker APIs and run the Docker. So that is a bit complicated. Just you know that when there are less number of Docker containers, they can be managed by Docker commands and Docker Compose. That is something I will show you later on in a forthcoming session. So these two are for managing lesser number of containers, but when it is a very big company having thousands of Docker containers, then you will need an orchestrator to manage it. So with this, we come to an end to today's session on Docker Essentials. Keep learning. See you around.